Some tests are designed to be administered with procedures so that there is consistency from test taker to test taker. This enables comparing test taker scores like apples to apples. Such tests are standardized, and they provide standard scores, which compare a test taker's performance to same-age peers. Knowing how standardized tests are created helps with understanding what standard scores really mean. First, the test developer designs a task, which could be solving math problems. The developer then gives the test to a group of people, called a norming sample, that represents the population, along the lines of things like gender, ethnicity, and location. Let's say the developer gives the math test to 100 16-year-olds in the norming sample. The scores of all of those 16-year-olds are folded together into an average or mean, which may be 26.7 correct answers out of 40 problems. On this math test, most of the 16-year-olds earn scores that are pretty close to the mean of 26.7 correct answers. Relatively fewer earn scores that are higher than the mean, and even fewer earn scores that are a lot higher. Similarly, few earn scores that are lower than the mean, with just a handful earning scores that are a lot lower. By the way, this is a bell curve, named for the shape that a group typically makes with a lot of members in the middle, near the mean, with fewer members at either extreme. Standard scores indicate how a test taker performed relative to the members of the norming sample, or where that person would be in the bell curve. Standard scores are computed by taking the points the test taker earns, called a raw score, and comparing them to the performances of same-age peers from the norming sample. For example, Jessie takes the math test and gets a raw score of 33. Now, 33 out of 40 may not seem too impressive, but considering that the mean of the norming sample was 26.7 and that she performed better than the majority of other 16-year-olds, Jessie actually did pretty well. So she would earn a strong standard score. In essence, standard scores are comparison scores that indicate how someone did relative to same-age peers. Again, apples to apples. Standard scores do not represent amount of ability, knowledge, or skill. Rather, they compare a person's ability, knowledge, or skill to that of other similar people. There are several types of standard scores, but they all are organized under the bell curve. Most standard scores have a mean of 100, such as intelligence or IQ scores. Subtest or scaled scores range from 1 to 19, with 10 being the mean. For T-scores, 50 represents average performance. With percentile scores or ranks, 50 is average. If a student earned a percentile score of 56, then his performance was as strong or better than 56 out of 100 other students his age who also took the test. Standard scores 85 or below are uncommonly weak. Same for subtest scaled scores of 7 or below, T-scores of 40 or below, and percentile scores of 16 or below. Standard scores 115 or higher are uncommonly strong. Same for subtest scale scores of 13 or higher, T-scores of 60 or higher, and percentile scores of 84 or higher. The average range is considered to be the middle of the bell curve, from 1 standard deviation below to 1 standard deviation above the mean. It may seem really broad, but percentile scores between 16 and 84 are in the average range. It all relates to the bell curve. Most people will score near the mean on a test, placing them in the big area under the curve, with relatively fewer towards the right with higher scores, or towards the left with lower scores. Whatever the metric, a lower standard score means most same-age peers performed better on that test. At 2 standard deviations below the mean, a standard score of 70 is the same as a subtest or scaled score of 4 and a T-score of 30, all of which are at the second percentile. So a 16-year-old who gets one of these scores performed better than only 2 out of 100 other 16-year-olds. Standard scores close to the mean represent performance that's typical for someone that age. A 16-year-old with one of these scores performed better than half of other 16-year-olds. A higher standard score means most same-age peers did not perform as well on that test. At 2 standard deviations above the mean, a standard score of 130 is the same as a subtest or scaled score of 16 and a t-score of 70, all of which are at the 98th percentile. A 16-year-old with one of these scores performed better than 98 out of 100 other 16-year-olds. Again, think of standard scores as comparison scores, apples to apples, or in this case, 16-year-olds to 16-year-olds.